Welcome back to another Orange Coast College mathematics video. In this video, we are discussing polar coordinates. Polar coordinates are another way of describing where a point is on a plane. In XY coordinates, you would move either left or right and then up or down. But in polar coordinates, we are going to have an angle by which we rotate and a radius by which we go out. So what do I mean by that? Well, let's jump into an example. In this particular problem, we've got 4, an r comma a theta value, a radius of 4, and an angle of 330 degrees. Well, we know 330 degrees looks like, you rotate around and you end up here at 300, and then this 4 means go out 1, 2, 3, 4. And so the point would be right here. Here at an angle of 330 degrees, but with the angle of, or a radius of 4. So this is 4, 330 degrees, that ordered pair. All right, in this next one, we have 120 degrees, where we go around 120 degrees takes us to there, 90 degrees plus a third of a quadrant. And so we're along this line, except, oh wait, it's -2. So actually I'm going to go in the opposite direction, 1, 2. And so this is the point, -2, 120 degrees. And then lastly, in this one, we have an angle of -pi/2. That means we're going this direction until we're at pi/2, and then down 1, 2, 3. And so I'm down here at 3, -pi/2. So you see here that this is another way of describing where a point is in the plane. Now that is half of the problem. But the problem also asked us to determine the rectangular coordinates, meaning this point in space, this point on a plane, how would we describe it if we wanted to use it with an x and a y value? Well, that goes back to just basic triangle trig. If I have a radius r and an angle theta, if I have a radius r and an angle theta, then the x and y will just be the legs of that triangle that's formed. And I know from my trig that the sine of theta is y/r. This means y is equal to r sine of theta. And similarly, the cosine of theta is x/r, so x is equal to r cosine of theta. And this is going to allow me to convert these equations. So, these points. So if I want to know for this part A, if I want to know what the y-coordinate is, it's going to be the radius 4 times the sine of 330 degrees. Or in other words, y is equal to 4 times the sine here is going to be -1/2 times -1/2 is just -2. Meanwhile, the x is going to be 4 times the cosine of 330 degrees, which we know to be 4 times, the cosine here will be positive radical 3/2, and I get 2 radical 3. And therefore, the ordered pair here, x comma y in rectangular coordinates, is 2 radical 3 comma 2. Comma -2, rather, because I got a negative here. The next couple are pretty similar. This might be a good opportunity for you to pause and try to see if you can attempt these on your own before I do them. Jumping into them, we're going to see that x is equal to r -2 times the cosine of 120 degrees. The cosine of this angle here is -1/2, so I get -2 times -1/2, which is 1. The y is going to be -2 sine of 120 degrees, which is -2 radical 3/2, which is negative radical 3. And therefore, my ordered pair in rectangular formula is going to be 1 comma negative radical 3. And lastly, moving on to this last problem, we've got x is equal to 3 cosine of -pi/2. Y is equal to 3 sine of -pi/2. Cosine of -3pi/2 is 0, so this just ends up at 0. Sine is -1, so I get -3. And so my ordered pair is 0 comma -3. All right, so far we've covered a couple things. We've covered how to plot points in polar coordinates and also how to convert them back to rectangular form. Well, what if we have an ordered pair that is in rectangular form and we want to represent it in polar form? Let's try this next example. Let's find two pairs of polar coordinates for the point given with the angle in the interval 0 to 2 pi. So notice they're asking us to find two pairs of polar coordinates. This seems to imply that there's actually more than one way to represent something in polar coordinates. Well, let me go back to this picture for a second here. There's a couple other things that I know. Yes, sine and cosine can be used in this triangle, but so can tangent, and so can the Pythagorean theorem. In this triangle, the tangent of theta is y over x, and also x squared plus y squared must be equal to r squared. These are going to be useful in these examples for converting back to polar coordinates. I will copy them here so we can reference them. For example, if I have this point in rectangular form and I want it in polar coordinates, we can find the radius by saying, well, r squared should be equal to what? Negative 4 squared plus negative 4 radical 3 squared, which means r squared is equal to 16 plus 16 times 3 is 48, which means I get r squared is equal to 64. So r is equal to plus or minus 8. Okay, what about the angle? Well, I know the tangent of theta is going to be equal to the y over the x. So that's negative 4 over radical 3 over negative 4, which is just radical 3. So in other words, tangent of theta is equal to radical 3 over 1. I can sketch a quick picture of this. When is tangent equal to negative over a negative? Well, that's specifically going to be down here in the third quadrant. So that's going to happen down here where I've got a triangle of negative 1, negative radical 3. And it also could be here because I'm getting a positive value. So it could be in either position. But because I know that these two are negatives, I know it's really going to be in the third quadrant. Well, this happens when I have a 60-degree angle here. So I'm looking at 4 pi over 3 for this angle. You could also be using your unit circle to reference. And so my theta is equal to 4 pi over 3. So there's a few different ways to represent this. The simplest is going to be a radius of 8 and an angle of 4 pi over 3. That is certainly an answer to this problem. We rotate by 4 pi over 3, we go out a radius of 8. But this said to find two pairs of polar coordinates for the point given with the angle in this interval 0 to 2 pi. So what I'm going to do instead is I'm going to also recognize that, hey, I could go just to this point using pi over 3, but then I could go negative 8 to still make me end up down here. So another point I could use would be like negative 8 and pi over 3. As a general rule, it's nice to use a small positive angle and a positive radius, but the point is there are actually infinitely many ways to represent a polar point, unlike in the xy coordinate plane where there is only one way to represent a point. All right, so for the next couple examples, let's just do a couple more. We've got r squared is equal to negative 2 squared plus 2 squared. That's r squared is equal to 8, or r is equal to plus or minus 2 radical 2. If I take the square root of that. And then the tangent of theta is going to be equal to opposite y value of 2 over negative 2, which is negative 1. We know that that happens at 45-degree angles, or in other words, pi over 4s. Where specifically? Well, here or down here at 3 pi over 4 or 7 pi over 4. But where else? Or rather, which of these is it? Well, negative 2 up 2 puts us in this second quadrant. So the point in question is very much this point up here. So I could represent this as an angle of 3 pi over 4 with a radius of 2 radical 2. That is one way to represent the point on the plane using this ordered pair. Or I could go to 7 pi over 4, but then I'd have to go back negative 2 radical 2. And of course, there's infinite many answers that would work as well, because we can just keep going around and around the unit circle. All right, lastly, this particular point is at 0, negative 3, and I'm trying to put this in polar coordinates. Rather than go through the exercise of actually plugging it into these equations, you'll probably realize that to get to this angle, I need to go to 270 degrees, or 3 pi over 2, and the radius is going to be 3. We can see that angle just by the geometry because we're on the y-axis. Or I could go to positive just a pi over 2, but then that would take me up here, so I'd need to use a negative radius to make sure I end up at the right spot. So here's a couple possible answers for this problem as well. All right, that'll about do it for this video. If you're feeling comfortable, you can move on to the next video where we will talk more about polar coordinates as well as polar equations.